Hello everyone. For my term project for operating systems class, I've chosen multiprocessing, and I will cover what is multiprocessing as well as give some examples of multiprocessing and then compare multiprocessing to multi-threading. So first off, what is a process? A process is like a job, and a processor would be like a human working on that job. The job can be done by different people, but only one person at once. So what is multiprocessing? Multiprocessing is like an employer spreading the jobs to employees. Some jobs can be done in parallel so that there can be more done than just one employee working at the same time. There's many factors to an efficient workforce. Employees have to collaborate in some areas and will have to wait on each other at other times. Much like this example, our computers process our programs similar to this fashion. How is a process set up on your computer? Programs are kept on a file on your system until they are launched, and then they will be loaded into main memory or RAM of your computer, similar to this fashion here. Instructions for the program are loaded into memory and then brought to the CPU to be executed. Um, so here's the example of the RAM and what the RAM would be holding. And they have all these intricate parts that are required for the process. The text section contains the program's code. The program counter contains where the program is currently executing. The stack contains all the temporary data that the program needs. And the data section contains all the global variables that the program will be using and will likely use again. And the heap will be the dynamically allocated memory for the program. Processes are managed by operating systems, such as Linux, macOS, Windows, Android, and iOS. And their operating systems are responsible for process creation, termination, and management. The operating systems will not always have the ability to execute every process at once and must be switched between processes, which is called a context switch. Context switches need a process control block to save all the information that the process currently has so that it can be paused and then brought back later. The process control block structure is as follows and contains the process state, what the current status of the process is, the program counter, where the next program instruction is, the CPU registers, the contents of them, the process structuring information, such as the child IDs and any other related processes, inter-process communication information, which contains flags and signals with independent processes. The privileges, what the privileges of the process is. The process number, which is a unique identifier. So for each process on the computer. The CPU scheduling information, such as the amount of CPU time the process has used, counting information such as time limits, um, time since started and time since it ended, as well as input-output devices and files that are in use by the process. Here is an example of how to create a new process pool in Python. A process pool is a pool of processes with a limit to how many processes can be executing at once. So the MP period pool limits 4 processes to be created at max. And any more than that, we'll have to wait until there is a process available to execute the job. And each process executes this job function, which waits 1 second. So here's the results of changing the amount of jobs with 4 cores or 4 processes. Here we can see the amount of time to complete under the amount of processing cores is near the same because our jobs are being completed simultaneously in parallel. After we pass this amount of cores, we can see the time it takes is longer than the original job because we are waiting for a slot to become available. Although we're still completing 4 jobs per second, nearly, with a little bit of time for process creation and termination. So what is the difference between multiprocessing and multi-threading? With multiprocessing, when we create new processes, if we have more CPUs, they can be accessed to complete these processes. Whereas with multi-threading, when we create new threads, more threads are added to existing process, but that one process will be executing on the same CPU. Processes creation does take more time as there's more components, and threads are more lightweight, so they take less time. Each process has its own address space in RAM or main memory, and each thread has shared address space. Processes can be executed simultaneously on different CPUs, whereas threads are executed concurrently. So each thread has one CPU, so it'll execute this thread for a bit, then maybe that thread, then maybe back to this thread on that same CPU. So that CPU can't execute more than one of these at once. So here you can see the difference between processes and threads with a graph. So when these are completed, down below it shows us seconds of time required to complete that task. So with multi-processing, we can see that 4 tasks are being completed simultaneously and end near the same time, and all 15 tasks are completed in a lower amount of time. Whereas with threads will have to wait between each other to complete their jobs and complete at a longer time. Thank you for viewing this presentation, and hopefully you can understand some of the advantages and disadvantages of multiprocessing.